Chapter 3. Now, you will read on your own, and I will just explain these diagrams. And this includes 7, 8, and 9, and you will understand them. A stored computer program will store the instructions in main memory and then execute them. So this is the process. It uses a fetch-execute cycle. Fetch means fetch the instruction from memory and decode it. Execute means execute the instruction. Okay, let's look at the first step. We copy PC to MAR, meaning we get the instruction address from program counter and put it in memory address register. And at the same time, the program counter is automatically incremented by 4 because each instruction is assumed to be 4 bytes. If it's 6 bytes, then you will increment by 6. So here we are saying an instruction requires 32 bits. So we increment it by 4 automatically as it gets the instruction. So that's step 1. That's MAR, PC to MAR. The next step is increment PC. We did that. And then once it gets to MAR, we have the address. We go to memory, get the content, the instruction, and put it in MBR. That is step 2. And step 3, from MBR, it's sent to instruction register, IR. So there is that data path. And then, so step 4, okay, now we have the instruction in the instruction register, and we have the operand's address, which requires us to go back to memory to get the content for the operand, because the operand is simply a memory address. So we go back to memory, address register, which the memory address goes there, and from there we go to the step 5. We go to memory, get the content for that operand, go to memory buffer register, and then from memory buffer register, we go to one of the registers. And then from when you, this is the fetch, right? And when you execute, those content from registers will go to ALU, 2 of them go to ALU, do the calculation, and come out and go to one of the registers. Now, if you have a literal in your instruction like this one, add R0, R1, $25. This hashtag is telling you that this is a literal, a value, a constant. So it's adding this constant 25 to the content in R1 and put it in R0. The constant comes from the instruction, so that constant will come this way and this way and go directly to ALU. That's how this works. The constant go directly from instruction register to ALU. Here we are talking about flow control, conditional behavior, jump. This is branch if equal to or branch if greater than. So now the next instruction to execute might not be a normal instruction, a normal sequential address. You see, sequentially, normally, you simply add 4 bytes. That means the next instruction is always 4 bytes after the current instruction. But when you jump, when you do a conditional statement, you actually need to calculate using the ALU to calculate the address. And now you get an address, it comes out, goes here, and goes to the multiplexer. You remember multiplexer accepts multiple inputs, and based on the control signal, which is here, 1 or 0, it will select one of the inputs as the output. So this multiplexer is choosing from the normal sequential address and this jump address, calculated address. So based on this control signal, it will select one of them. That's what this means. And if you notice, this is the bits that control which address is selected, and we will discuss those in chapter 7 more.